Hello, my name is Kamsinah binti Kamsul and my matric number is 07DKM22F 2017.
My name is Nurisma binti Jakarta and my number matrix 07DEE23F1082.
Good evening. My name is Dexter Eronosius and my matrix number is 07DKM22F2005.
First, I will explain about introduction of differentiation. Differentiation is a fundamental concept in mathematics, especially in calculus. It helps us understand how things change. Another name for differentiation is derivative of the function. Secondly, differentiation helps you find the speed or rate of change at any particular point in your journey. In terms of maths, differentiation is like a special tool we use to find the slope of a curve at any point. Differentiation gives us a formula to find that slope precisely. Differentiation concepts are applied in displacement and velocity. Velocity v is the differentiation of displacement. S into time, t and it's written as dw over dt, while acceleration a is the differentiation of velocity v into time, t and it's written as dw over dt.
Example of application of differentiation in real life. Differentiation can be applied in our daily problem. We can use the differentiation to determine the maximum and minimum value of particular functions such as cost, strength, and amount of material used in a building. And also used in many engineering and science problems, especially modeling the behavior of moving objects. For instance, if you have a formula that describes how a ball moves as it's thrown, differentiation can help us figure out how fast the ball is traveling at any specific moment. It's all about understanding change and speed in the word of the number and function. For the next, I want to explain about stationary point and turning point. A stationary point on a curve occurs when dy over dx equal to 0. There are three types of stationary point. The first one is maximum point, the second one is minimum point, and the last one is point of inflection. This is some of the example of the drawing of the graph for maximum point, minimum point, and point of inflection.
So now I'm going to show you and explain how to solve this equation to find the stationary points. First, we have to find the value of x. How to find the value of x? It's simple. We just have to factorize this equation and put it into the first order. Like we see in this slide, 3 times 2 equal to 6x power of 2, 2 times 3 equal to 6x, negative 12x and negative 7, we're going to get negative 12. When we get the answer, we have to use the calculator and we push the mod button 3 times and we pick number 1 is equal n until we get the degree, and we're going to put the answer that we get from the equation into the calculator. A is equal to 6, B is equal to 6, and C is equal to negative 12. And we're going to get x1. My x1 is 1 and x2 equal to negative 2. Now we are going to step 2. Step 2, we have to find the value of y. How to find the value of y? It's simple. We just have to put the answer that we get from step 1 into the equation. Like we can see in the slide, when x is equal to 1, we're going to change all the x into 1. We can see, like you can see in the slide, 2 bracket 1 power of 3, 3 bracket 1 power of 2, and so on. And then we're going to get negative 14. Next, when x is equal to negative 2, we're going to change the x in the equation into negative 2. And we're going to get 13. So now for step 3, we have to state the stationary points. We already get the answer from step 1 and step 2. Now we just have to state the answer. Therefore, the stationary point is 1, negative 14, and negative 2 and 13. Step 4, we just have to determine the nature. We already get the first order from step 1. Now we just have to factorize it again to get the second order. When we factorize the first order, we're going to get 12x plus 6. So now, when x is equal to 1, the second order is going to be 12 bracket 1, and the mean point is 12 is bigger than 0. So when x is equal to negative 2, the second order is going to be 12 bracket negative 2, and the maximum point is going to be negative 24 less than 0. Now for the last step, step number 5, we have to sketch the graph using the answer that we get from the equation that we solve. I'm using the GeoGebra apps, and this is the graph that I get. Thank you.
So here our conclusion for this topic, divided to 3 parts, which is concept of change. Differentiation is all about understanding how things change, how quantities or functions evolve as their inputs vary. Secondly, key calculations. It involves formula and rules like the power rule and product rule to calculate derivative and understand how functions behave locally. Lastly, real-world applications, widely used in science, engineering, economics, and more to analyze and optimize process, predict outcomes, and solve practical problems. In summary, differentiations help us grasp change, calculate instantaneous rates of change, understand local behavior, and apply these concepts to a wide range of real-world scenarios. That's all from us. Thank you for lending your ears. I hope this is useful for you guys. That's all. Bye.